Welcome everyone. Today you'll be building this full stack online chat application all in Java. In this project, you'll learn advanced techniques using the Swing framework to build the front end and utilize Spring Boot's WebSocket library to create the back end. The main features of this app will be to connect our client GUI to our WebSocket backend server, where connected users are able to send messages to each other, and the other feature is being able to see who is currently active and connected to the WebSocket server. Later on, we will be hosting our WebSocket server online so that you can interact with people all over the world. So if that sounds interesting, let's begin. Alright, so before we begin, we'll first need to install Maven. If you don't know what Maven is, it allows us to easily install the necessary dependencies for this project to work. Alright, so first we're going to go to this site here. And I'm going to leave a link down in the description. And then what you want to do is go down here and then we're going to download the binary zip archive. So to do that, we're going to have to click on this link here and then just wait for the download to finish like this. Then you'll want to locate the zip file that we just downloaded. And then we're going to extract its content. But for me, I'd like to put it in my program files folder. So I'm just going to cut this, go to my system, go to program files, and I'm just going to paste it directly into here. It might do this, just hit continue. And then once it's here, we're going to right click the RAR file and then we're going to select the extract here option. And if a message pops up, just hit OK or confirm. And once it's done, we should have our folder right here. So next we're going to go to our search bar and we're going to type in environment. And then we're going to hit the first option that shows up. And then this pop-up should appear. It's going to be the system properties. And then we're going to click on the environment variables button. And then this pop-up should appear. So what we're going to do in the system variables, we're going to locate the path variable. And then we're going to highlight it. And then we're going to hit edit. And then here, as you can see, I already have a previous version of Maven, but we're going to want the most updated version. So what we're going to do is go back to the file explorer and then we're going to highlight this folder and we're going to click on it, double click on it. And to get the path, we can see here, all we have to do is just click on this here and then we should get the path. So we're going to right click it, hit copy, go back to our environment variables and then we're going to hit new. And then we're going to paste that path into here, but also we're going to type in a backslash and bin. And since I'm using an older version, I have to make sure this is higher than this. So we're just going to move it up and then we're going to hit OK and then just leave everything as normal. I do want to note that you might get some issues if you don't have a Java home variable, as I've encountered it myself. So if you do get some errors saying that Java home isn't declared or something, just make sure to add this variable and then the location of your JDK. And then once we have all of that, just hit OK and then hit OK. And that should be it. And to check that it works, we're going to go to our terminal and we're going to type in this command, mvn --version. And then we're going to hit enter. And there we go. So we have the most updated version of Apache Maven at the time of this video, which is 3.9.8. And that's pretty much it. All right, next we're going to create our Spring Boot project and we're going to be heading to this site to generate it for us. And this is Spring Initializer, which is a quick way to bootstrap a new Spring Boot project. And on this page, you'll see several of these fields and then we're just going to fill them out. So for project, we're going to select Maven. And then for the language, of course, we're going to select Java. And then for the Spring Boot version, I'm just going to choose the most stable version, which is going to be 3.3.2. But depending on when you're watching this, it might be different. And then below here, I'm just going to select jar for packaging. And then for Java, I'm going to use the most recent version, which is going to be 22 at the point of this video. And then for the artifact, I'm just going to name it WebSocket Demo. And then notice that it automatically updates the other fields as well. We're just going to leave it like that. And for the description, you can just pretty much say whatever you want to describe the project. I'm just going to leave it as default for now. And then if we go to the right side, we're going to add these dependencies. So we're going to click on the Add Dependencies button. So at the top, we can search up all the dependencies that we want. And then the first dependency that we're going to add is the Spring Web. So it's going to be this one. You're going to want to click on it. And that's not the only dependency. We're going to add two more. So click on Add Dependencies again. So we're going to search up WebSocket. And we're going to select the only option here. And then the last dependency that we're going to add is Springboot Springboot DevTools. And that's pretty much it. So once you filled out all the fields and added the dependencies, we're going to go to the bottom here and we're going to select generate, which is going to download the project, and we're going to save it somewhere you'll remember. I'm just going to save it here. So no, if you change any of these settings in this video, as in like changing the artifact, the name, or the description, or actually the description doesn't matter, but like let's say the artifact and the name, I want you to take a snapshot of these settings, as we'll be needing these later on when we're going to host this WebSocket on render. But for now, just make sure that you are using Maven and that you're using, for the packaging, you're using jar. That's the only requirements, because it's going to make it a lot easier to set up on render. So once the download's finished, we're going to locate the file that we just downloaded, and then we're going to extract it. For me, I'm going to move it to a different folder, or I'm just going to make a copy of it into Springboot projects, which is what I'm just going to name the projects. I'm going to do Springboot projects in. Then we could just delete the zip file. And yeah, so then we could run this in our favorite IDE, IntelliJ. So let's head over to our IDE right now. Once IntelliJ is loaded up, you're going to want to open the project, and then you're going to locate that folder that we extracted from that zip file that we downloaded, and then you're going to highlight it. In this case, it's under the Springboot projects that I just created, and it's called WebSocket Demo. And we're going to highlight it, and then we're going to click OK. And here, just hit trust project because it was generated by Spring, so we could trust them. So this is how the project structure looks like. All right, so first what we're going to do is we're going to locate this Java file. It's going to be under source, main, Java, and under this package. And we're going to double click on it. It's going to be called WebSocket Demo Application. So first thing to notice is that we do have this at Springboot application annotation. And what this means is that it marks our class as the main entry point for the Spring Boot application. You can tell that because it has the main method in here. And in the main method, we're calling this line of code here. And this basically starts up the Spring Boot application in a Tomcat server, or the WebSocket uses the Tomcat server. And the Tomcat server is the default embedded servlet container for Spring Boot applications. And all you need to know is that when we include the WebSocket dependency from the project that we added earlier, Tomcat automatically sets up everything needed to support WebSocket connections, which is good because we're going to be utilizing WebSockets. All right, so here we're just going to run the program and see what the output is going to be. So yeah, that's a lot of text. But don't worry, you don't need to know too much at the moment. All I want to focus on is that in this line of code here, or sorry, not line of code, in this line here, notice how it says Tomcat initialized with port 8080. So this is important because when we run our WebSocket, it's going to be in our local machine on port 8080. And this is the default address for our local server. It's where we'll be able to interact with our WebSocket locally. But later on, we're going to host it on render, which will then use a URL. But we'll get into that later on. All right, let's just close this for now. All right, so the next thing we have to do is configure our WebSocket. And we're going to create a class called Websocket Config that basically sets up our WebSocket communication. And this class has some important annotations and methods to it. So we're going to briefly go over them. The first one is going to be at configuration. This tells the Spring framework that this class is a configuration class, which helps with setting up the parts of our application. And then the next annotation is called enable WebSocket message broker. And what this does is that it enables WebSocket message handling backed by a message broker. Now, what's a message broker? To put it simply, a message broker is a software that enables applications, systems, and services to communicate with each other and exchange information. In this case, we'll be using message brokers to help manage the messages coming from and to our WebSocket server. And then this class is going to implement the WebSocket message broker configurer. And this interface provides the methods to configure the WebSocket and message broker. So here we're going to override two methods. The first method is going to be configure message broker. And in this method, we set up a simple in-memory broker where the /topic is a route that our WebSocket server will broadcast the user messages to. Then here, it sets the prefix for messages going to our controller. So messages starting with the /app will be handled by special methods in our controllers. Don't worry if you aren't following whatever I'm saying now, because once you see the client code, you'll probably get a better understanding. But for now, know that we will be sending messages from the client to the /app route, and then receive messages from the client to the WebSocket server in the /topic route. And the next method that we're going to override is the register stomp endpoints method. And what this does is that it registers the stomp endpoints. And stomp stands for Simple Text Oriented Messaging Protocol. It's a protocol that our WebSockets will follow, making it easier for different clients to communicate with it. Here, we register the /WS endpoint for WebSocket connections. This is the URL clients will use to connect to our WebSocket. And with the with sock.js call, it enables sock.js fallback options. And sock.js is a library that provides WebSocket-like behavior for browsers that don't support WebSockets. So it's like having a backup plan to ensure everyone can connect, even if their browser is outdated, or in our case, we're using a Java GUI, which is going to be using a sock.js client later on. So next up, we're going to be creating our controller class, which will be handling the logic for when a user sends a message to the WebSocket server. So let's create that new class right now, and we're going to call it WebSocket controller. And then I'm going to hit enter, and we're going to create this new class. So first, we're going to add the @controller annotation. And what this annotation does is it marks this class as the Spring MVC controller. This is the class that will handle the web request or the WebSocket request. So first, we're going to be adding this private global variable, which is of simp messaging template type. And this is going to be used by our WebSocket to send messages to our client. And don't worry about the red squiggly lines right now. It's only doing that because we need to initialize it, which we'll do in just a minute. And so next, we're going to create the constructor. So here, notice how it's using the @AutoWired annotation. And what this is that it's part of Spring's dependency injection mechanism. So for example, it's going to tell Spring to automatically inject the required dependencies when creating an instance of the WebSocket controller. In our case, Spring will provide an instance of the messaging template and other parameters that we include in this constructor, which we're going to do later on. So you can just think of it as a way of Spring initializing this object for us. Next, we're going to create this method here, handle message, and ignore the errors for now. And let's focus on the @message mapping annotation. So what this annotation means is that we're going to bind this method to the -app-messages route, where it will handle incoming messages. So you might be wondering where the -app comes from. Even though we don't mention it here specifically in the annotation, it's automatically applied because of the config, because of our configuration class, because of this line of code. So whenever we do a message mapping and we create a route like this, it's going to append whatever route we added here. So for example, from our client side, or the GUI, we're going to be sending the message to the localhost port 8080 because that's where our WebSocket server is currently being launched. And then it's going to append the /app/message, and then this method is going to process that message. First up, we need to create this message model. So let's go over here, and then we're just going to right click again, new Java, and then I'm just going to insert message. So this class is going to be a POJO, which stands for a plain old Java object. So the message model is going to have two properties, a user and a message. They're both going to be string type. So next we're going to create the two constructors. The first one's going to be the default constructor, and then the next one we're going to be using to instantiate the user and message properties. And then we'll also be creating these helper functions to securely retrieve the user and message values. And that's pretty much it. So let's go back to the controller, and now the errors are gone, so that's good. So now let's dive deep into what this method is going to be doing. So here I'm just going to have some system.out just for debugging purposes. You don't need to do it if you don't want to. And then the next one we're going to utilize our messaging template, and we're going to call on the convert and send method, which will take in two parameters. First is going to be the destination, as you can see here, and in the destination we pass in this route. And I want you to pay attention to the /topic route or the /topic part, because if we go back to our config, that's where our message broker is going to be at. And the message broker is what our WebSocket's going to use or to broadcast the messages back to the clients or the users. Go back, and then another system.out just for debugging purposes again. So the route /topic/messages will be used by our WebSocket server to broadcast the user's message to all the connected users. And how this works is that in our client side, we're going to be subscribing to this route, and whenever a message gets sent to this route from the WebSocket, the clients or the users that are subscribed to them will listen to them. And you can think of it like subscribing to a newsletter or a newspaper, where our WebSocket server is the newsletter company, and whenever a new newsletter comes out, it'll automatically be sent to all the subscribed users. So now we can start working on the client side and then start testing our WebSocket server. So here I'm going to create a new package, and I'm going to call this client. And in this package, we're just going to have all of the client code. So in the client package, we're going to create a new Java class, and we're going to call it myStompClient. We're going to hit enter. So first, we're going to add these properties. We're going to add in a stomp session and a string username. So stomp session allows us to connect to stomp servers, which is what our WebSocket server is going to be based on. And it has methods that we could use to send messages, subscribe to topics, and manage the connection. And then for the username, we're just going to store in the username of the client. And next, we're going to create our constructor, which will take in a username, and we're just going to store that username into our username property. So remember in our WebSocket config where we assigned the SockJS protocol to our WebSocket? Well, now we're going to have to create a SockJS client. This might get a bit confusing. So here we're going to first create our transport. And transport in the context of web communication refers to the method or protocol used to transfer data between the client and server. And what we're basically doing here in these two lines of code, you can think of it as a way to allow our SockJS to communicate properly with a WebSocket server. But the issue still lies in that the SockJS client by itself doesn't support the stomp protocol. That's where the WebSocket stomp client comes in, where it'll take our SockJS client and then basically allow us to use the stomp protocol with it. So now with this, we can start sending or interacting with our WebSocket from our client code. So the next issue that we have to tackle is how we're going to manage the data that we're going to send to the WebSocket, and also when we receive data from our WebSocket server. And a solution to that is to call on our setMessageConverter method from our stomp client and then pass in a mapping_Jackson2 message converter object. And what this is basically doing is it allows our stomp client to automatically convert the Java objects that we're going to be sending to the WebSocket as JSON data, which is a commonly used format when we're sending data through a network. And then this also allows us to interpret JSON data and then convert it back into the Java objects that we're going to be using, which is our message model. So this basically simplifies the process of working with JSON in our WebSocket-based application, because we really don't need to manually serialize and deserialize the JSON every time. So it basically does all the work for us. So next, we're going to need a way to manage our stomp session. So to make things cleaner, we're going to make a separate class that will handle our stomp session. And what this class will basically be used for is managing our connection with the WebSocket. So this includes like what should happen after the user connects, or what happens after disconnects, and basically all of that stuff. So first we're going to need to create a new class. So we're going to go here again, and then we're going to just create a new Java class. And then I'm just going to name it myStompSessionHandler. And then once we're done, we're just going to hit enter. And now we have our new class. So the first thing we're going to do is we're going to make this class extend the stomp session handler adapter. And then we're going to override these methods. So the first method, after connected, is going to be used once the user has successfully connected to the WebSocket. So after we connect to our WebSocket server, we're going to automatically want to subscribe to the topic messages route. And as a reminder, this is where the WebSocket server will broadcast all of the connected users' messages to. And to do that, we're going to use our stomp session object and we're going to subscribe to that route that I just mentioned. And then in the second parameter, we're going to instantiate a stomp frame handler object. And what this class enables us to do is use these methods, which can handle incoming messages that are being sent to the destination that we subscribe to. So the get payload type is used to inform our client about the expected type of the payload. And what they mean by payload is the data that's being sent to the destination. And here we're going to return a message.class. So it's going to convert the incoming JSON data and then convert that into a message object. And then our other method, handle frame, is going to first check if the payload is of a message type. If so, then we can store that data as a message object. And also we'll need to have a username property, which we'll be using later on. And we're also going to create our constructor, which we'll take in the username and just store it into the username property. All right, so let's head back to the MyStomp client, where we will instantiate our new class and pass in the username. And then next, we're gonna need to create our URL that we're gonna use to connect to our WebSocket. And as a reminder, by default, your WebSocket server should be running at port 8080 at your local machine, which is where localhost comes from. For the WS, it just stands for WebSocket. And then this /WS comes from our config, where we added that endpoint in here. So finally, after configuring our stomp client, let's finally connect our session to our WebSocket server. So we're going to instantiate our session by calling on the connect async method from our stomp client, where we're going to pass in our URL of our WebSocket and our session handler, which is going to handle the messages that we're going to receive. And right now we're getting an error. That's because we need to capture these exceptions. So to test this out, we're going to create another Java file, and this is going to be where our GUI code is going to be, but for now I'm gonna hold off on that until the very end, once we have the backend fully sorted out. So I'm just gonna name it ClientGUI. So here I'm just gonna create our main method, which is gonna allow us to execute code with this class. So now we're going to instantiate our MyStomp client. I'm just gonna name it like this. Then we're gonna pass in a username. I'm just gonna enter a random username. I'll just say tap. So we're getting errors here because we also need to throw the exceptions that we've thrown in the session handler, or I mean the MyStomp session, or MyStomp client. All right, so if your WebSocket server is still running, you can close it for now. And what we're gonna do is we're actually gonna create a configuration for it so that we can execute two Java files at the same time. So if you're using IntelliJ, just copy what I'm doing. So once we're here, click on application, and then here we'll call it WebSocket server. And then for this field, we're gonna click on this icon here, and then we're gonna select WebSocket demo application, which is what our Springboot WebSocket server code is currently being stored at. And then we're gonna hit apply and then OK. And let's run our server first. So we're gonna hit the run button. And as you can see, our WebSocket server is running right now. And then, so for this, we're just going to use this current file, which is a feature for IntelliJ where it'll just execute the current file if it has a main method. In this case, it does. So let's run it right now. All right. Actually, I forgot to add the debug code. So let's go to the MyStomp session handler class. And then in our after connected method, we're going to we're going to do a system.out. And we're just going to say client connected. And then we're also going to do a system.out after we subscribe to this route. And we're just going to say client subscribed to /topic messages. All right, so our WebSocket server should still be running. And now let's run the client GUI again. And there we go. So we were able to connect to the WebSocket server and also subscribe to the topic messages route. And that's how we know that our code is working so far. So now let's create a way to send messages from our Stomp client to the WebSocket server. All right, and to do that, we're going to create this send message method where we're going to use our Stomp session object, and we're going to call on this send method, and here it'll take in two parameters. So first, it's going to be the destination where we're going to send our messages to, and this route here /app/message. If you don't remember, you can go back to our controller class. That's what this method is, or that's what this route is connected to. So any messages or any data that's being sent to app message, this method is going to handle that incoming data. And go back here. And then we're going to send in the message object, which is a requirement for this method. So when we're calling this method, we're going to have to create a message object that we're going to send. So let's go back to our client GUI, and this time around, we're going to call on the send message method. So we're going to call on the send, and then we're going to pass in a message object. So we're going to say new message, and then for the user, I'm just going to say tap. And then for the message, I'll just say hello world. And let's import this class to our project. It's going to be the one that we made. So don't use any of the other message classes. All right, so let's test this out now. So the WebSocket server is still running. If it's not, make sure to run it again. So in our terminal, we can see that it said message sent hello world. But now let's look at our WebSocket server, because in our controller, in our handle message method, we debugging the message, and then we're also sending it to topic messages too. All right, so yeah, I think it kind of refreshed a bit, but if we scroll up here, we can see that it did receive the message. So here, received message from user, tap hello world, and then we also sent that message to the topic messages route. And I guess we should have also debugged when we received the message too. So let's go to our my Stomp session handler. I wonder why it didn't do that. Oh yeah, so I think I remember now. So that's because by the time we sent it, our program terminates. So we'll have to test this later on when we make our GUI, because in that way our program's going to keep running. Yeah, our program's going to keep running until we close the GUI. So for now, just know that it does work, and then we're also able to receive the message. Let's close this for now. So now since we're able to send messages from our client to the WebSocket server, the next feature we're going to add is the ability to see who's connected to the WebSocket server and send that list to our client. So first, we're going to have to implement that logic into our WebSocket server. So to do that, we're going to have to create another class. So we're going to go here, we're going to right click, new Java class, and then we're going to create a class called WebSocket Session Manager. So first up, we're going to add a @service annotation. And what this annotation does is that it indicates that this class is a Spring service component. And Spring will automatically detect and register as a bean in the application context. And as a reminder, you can think of a bean as an instance or an object of the class. So this basically means that Spring will create an instance of our WebSocket Session Manager and will manage it for us throughout the project's runtime. So this is the class that's going to manage the connected users. So we'll need to use a data structure to store all of these users. And for this project, I decided to use an array list, in which it'll store in string objects. In this case, it'll just be the usernames. And I also chose array list because it can allow for duplicates of usernames. And if that's something that you don't want to have for this project, you can change it up. But I recommend you do that after the project's finished, like you can at least you at least know that the project is going to be working by the end of this video. So in our session manager, we're also going to be sending messages to certain routes. And to do that, we'll also need our simp messaging template that we created in our controller class too. And we're getting this error because we need to instantiate it because we are making it a final variable. So we're also going to create our constructor here with the @AutoWired annotation to inject the required dependency. In this case, it'll be the simp messaging template. And something to note too is that Spring follows a singleton design pattern. So this messaging template is going to be the same as the one we used in our controller class too. Just something to think about or something to know. So next we're going to be creating the methods that's going to interact with our array list. And those methods are add username and remove username. And they do exactly what they're named, in which we just add it to our array list or remove it. And now the more interesting method is going to be the broadcast active usernames method. And we're going to use our messaging template to send the array list of users to the topic users route. And then I also added system.out so we can debug it later on. We can't test this method just yet, as we'll need to connect the client such that it gets added to the active usernames list first. And we'll head to the WebSocket controller just to do this. So first up, we're going to need a reference to the WebSocket session manager. And then we're also going to update our constructor to take in a WebSocket session manager object. And then we're just going to instantiate the session manager to the parameter. And this works because we have the @AutoWire notation working in the back, which Spring manages for us. It's going to instantiate an object for us. So just like how we created a method where it will process messages being sent to the /message route, we're going to create 2 more routes and 2 more methods too. So the first one, connect user, and it uses the @message mapping annotation. So whenever we send messages to /app/connect, this method is going to handle that data for us. And in the method, it's going to use our session manager and then call in the add username method to add username to the array list. And then after that, we're going to call on the broadcast active usernames, which is going to send the list of users to the topic users route. And then the other method that we use is called disconnect user, and we're going to use this to process disconnections, and it follows the route app/disconnect or /app/disconnect. So when we send a username to the destination /app/disconnect, we're going to want to process it in a way to remove the user from the list. And then we're also going to we're going to provide an update to the connected users with the most updated list. Then another system.out for debugging purposes. So now once we have these 2 methods, let's connect our client to our WebSocket. So let's go to our MyStomp session handler class. And in our after connected method, the moment we connect, we're going to send a message to the app connect route, and we're going to send them the username of our client. So again, when we send a message to this route here, this method is going to process that. So the username that we send from here is going to be passed as this parameter, and it's going to call on our session manager to add the username to the list and then broadcast the users to the user's topic route. And let's test this out. So again, make sure your WebSocket server is already running, and then we're going to select current file, and then we're going to have to go to our ClientGUI code so we can test it out. So what are we expecting when we run this code? So again, when we run this code, we create an instance of MyStomp client, which has our MyStomp session handler that handles the connection of our client to the WebSocket. So when our client connects to the WebSocket, it's going to send the username to our WebSocket, and then this method's going to execute. And then we should see this in our terminal when we're looking at the WebSocket logs. All right, so let's execute this now. This is fine. So let's go to our WebSocket server and let's take a look. And here we go. So there's this message here that says tap connected. So that's what this line of code gets executed. And also notice broadcasting active users to this topic users route, and that's from the WebSocket session manager when we in this method here, where it would send the list to this route, and then we just have a system.out just mentioning it. So now we got the connect user to work. Let's get the disconnect user to work next. So for that, we're going to go to our MyStomp client class, and then we're going to create a method. So we're going to create a new method called disconnect user, where we'll take in a username as a parameter, and then we're going to use our same session to send a message to the app disconnect route and then the username. And app disconnect route is connected to this method here, where it will remove the username from the list and then broadcast the updated list to the users again. And then we just have another system.out for debugging purposes. So now let's test it out. So let's go to our client GUI. And so we instantiate a MyStomp client and send a message. So now we're going to disconnect the user, and the user is going to be tap because that's the username. I should have put this in a variable username, but I think it's already too late. We're going to delete this later on. So what we're supposed to expect here, so it's going to send a message first, and once it's done sending the message, we're going to call on the disconnect user method from our MyStomp client, where it'll send this route, the username that we passed in. And then what that's going to do is our WebSocket server is going to receive that, and it's going to process it with this method where it'll just remove it from the list and etc. So let's try this out now. So first up, we can see this debugging message, which comes from the MyStomp client method where it disconnects the user. Now let's go to our WebSocket server logs, and we should look for this one, tap disconnected. So in the controller class, that's what this line of code does. It outputs that this user has disconnected. And also another thing, so here this is when the user connected and it sent a list, and here's the current list when the user was still connected. But when we disconnected, it also broadcasted the updated list, where the list is now empty because we removed tap from the user list. Alright, so now we're pretty much done with the WebSocket server side. So now let's start building our GUI. So we're going to go to our ClientGUI class. Alright, so first we're going to remove our main method, and then we're going to make this class inherit the JFrame class. Let's just remove, actually we can just leave those for now. So let's make our constructor. And then for the parameter, it's gonna take in a username. And then we're gonna call on the super method to instantiate our JFrame, since it inherits. It's gonna call on the parent constructor, which is gonna be the JFrame constructor. And one of the JFrame constructors that we can use is we can give it a string, which will then add text to the header. And for the header, what I'm gonna do is just display the username. So I'm gonna say user, and then the username. So next I'm just going to configure the GUI, and first I'm going to give it a initial size, and we're going to use a set size method, and we're going to pass in these two values, 1218 by 685 pixels. And if you're wondering how I came up with this number, it's usually trial and error, and sometimes I use like a software called Figma, and that's where I designed it, and then I just kind of mess with the values till I get something that looks good, and then I'm just using that value. And then we're going to call on the set location relative to method, and then we're going to pass in null. And what this does is it loads our GUI right into the center of our screen all the time. This is just something for preference, and I think that should be good for now. So the next thing we're going to do is we're actually going to create another class, which is going to be our main access point to our client. So we're going to highlight the client package, right click, new Java class, and we're going to call it app. And then in this app, we're going to create our main method, and then we're going to call on swing utilities dot invoke later, where we're going to pass in a new runnable. And whatever code we put in our run method is going to execute under the swing utilities. And the main reason why we want to do this for swing GUIs, it makes updates to the GUI more thread safe. So you don't need to know it too deep. Just know that it's just good for updating the UI for the swing framework. So now let's instantiate our client GUI. So we're going to create client GUI object, and we're going to need to pass in a username. Right now, we're going to get the username through user input later on, but for now, I'm just going to type in a static username, which is going to be tap again, and then client GUI set visible. And this is important that you call this at the end, because if you call it like let's say you call it right here, it's going to display the GUI before you made these updates before we configure the GUI itself. So it's safe to just have it at the end, just to make sure that everything loads in properly before it gets displayed to the user. All right, so now we're gonna just use the current file again, and then we're gonna execute this application or this app file. And there we go. So right now this is how our GUI looks like, but don't worry, we're gonna make it better and we're gonna make it functional. All right, so let's close this for now. And actually, so even though we closed it, notice how the program is still running. If we look up here, we have two processes that are currently running. One is the WebSocket server and the other one is our application. And the reason why is because JFrame's main default close operation is to hide on close. So when you press X, you're not actually closing the software, you're just hiding it away. And we don't want that, because imagine if you're playing a game and you closed it, or you're using any software and you wanted to close it, but it was still running in the background. And yeah, this doesn't sound good at all. And we can fix this easily by setting our default close operation to exit on close, which is it will end the process of our program, which will then release the resources that our program was using. But I kind of want to make it more interesting, and I want to add like a pop-up dialog when the user presses X, asking if they want to close it. And you can see an example of it right now. So yeah, so let's implement this feature now. So let's go back to our client GUI. So again, the default close operation is to hide on close, and we don't want hide on close and we don't want exit on close. Luckily, there's another operation that we can do, and it's called do nothing on close, and it does what it says. It does nothing. So when we press X, it's not going to do anything. And I guess I could show you guys real quick. So right now, let's just end the process again. I forgot to do that. So let's run the application again, and then let's press X. So right now it's doing nothing. You can't even close it, which is also terrible, but we're gonna add something to make it so you do close it. So just end the process now, and then let's go back to our client GUI. And now we're gonna add a window listener. And what this window listener allows us to do is listen for events that are related to our JFrame, such as when it gets closed, when it opens. You can see what these methods are able to do. And the one we're interested in is window closing. So we're just gonna override this method. And note we're using the adapter so that we don't have to override each method. So I think that's pretty neat. So we're just gonna delete this. And for the dialog, we're not going to use JDialog. Instead, we're going to use using the JOption class, JOption pane class. And then we could show a confirm dialog where we're going to pass in this instance of our GUI, just so it loads relative to the center of our GUI. And then the second parameter is going to be the question that we asked the user. In this case, we're going to ask them, do you really want to leave? And then the third parameter, we're going to have the title. So it's going to appear at the top left of our header. So here I'm just going to say exit or something like that. Yeah. So the fourth one, it allows us to control the number of buttons we have, or how the layout should be. And then for here, we're just going to just say yes or no. So it's gonna show a button. It's gonna show a yes or no button. So because there's two options, yes or no, this actually returns a value, an end value to be specific. So we can actually store the user's input into an integer. So we're gonna create a reference so we know what the user chose. We're gonna call it option, and then if option equals JOptionPane dot yes option, then we're gonna want to dispose this GUI. So we're gonna say ClientGUI dot this dot dispose. All right, I know that was a lot, but let's try this out now. So our GUI's loaded, and I also forgot to mention, but this is the title, where the title goes. So in this case, user, and then tap. All right, so next, you know how before we would press X, it didn't do anything? So now let's press X now. Oh, so now we have a pop-up dialog with the exit header, the question that we asked, and yes or no. So if we click on no, it's just gonna close the window, and notice how our GUI is still here. So let's try it again, but this time let's say yes. And there you go. And notice how the process also ends too. So now when we close our GUI, it releases the resources along with it. If you're liking what you're seeing so far, please leave a like, as it really helps the channel grow and it helps with the algorithm. Also, sharing is caring. Alright, so now let's start building our GUI up. So let's go head back into our ClientGUI class. So first, as you saw, our GUI was pretty bland. Let's add some color to it. So what I would recommend is to create a utilities class that we can call on and reference to so that we can configure our GUI pretty easily. And I'll show you in a second what I mean. So let's go to our client package, right click new, Java class, and we're going to call it utilities. So in our utilities class, we're going to declare the 3 types of colors that we'll be using. And that'll be transparent color, primary color, and secondary color. You may be wondering why we need a transparent color, and the main reason we're going to do it is because most components come with a default color, and supplying them with a transparent color, because most GUI components come with a default color, so we need to make some of them transparent. So the next thing is our primary color, and we're going to use this color. You can choose a different color if you want, but I find these 2 colors to be compatible and looks pretty decent. And yeah, so that's good for now. So let's head back to our client GUI, and now let's update the background color of our client GUI. So to do that, we're gonna call get content pane, and then set the background color to be utilities dot primary color. All right, so now let's run this again. All right, so actually I'm going to configure the client now since we have our app class. So to do that, you can skip this part if you don't want to do it, but we're going to have to do it anyways later on. So we're just going to configure our access point. So we're going to call it app, and then for here we're going to click on this one and just leave everything the same, and then hit OK. So yeah, let's just run it now. And yeah, so there you go. So we have a neat background color. All right, next we're going to start adding the GUI components. So let's close this for now. Go back to client GUI, and then after we declare the color, we're going to call a method called add GUI components. And we haven't made this method yet, but I like doing it like this to decouple the code a bit, just to make it more organized. We're going to create private void add GUI components. So how I want the GUI to be broken up to is we're going to have the users list, which is going to be on the left side, and then the main chat components are going to be on the right side. So we're going to create another method called add connected users components. So first we're going to actually create a global variable called connected users panel. And what you can think of JPanel is, it's like a container. So for those web developers out there, you can think of JPanel as a div. So let's go back to our previous method, and we're going to instantiate our user panel, and we're going to give it a layout manager of box layout. So new box layout, and it'll take in 2 parameters. It's going to take the container target, which is going to be our connected user panel, and then the second parameter is the axes at which the orientation of the box layout. So do we want it to be in the y-axis, like horizontal, or I mean vertical, or do we want it to be horizontal? And for this case, we're going to want it to be horizontal. So we're going to say box layout y-axis. Next, we're going to add a background color to our users panel. So we're going to call in the set background method, and then we're going to call in the utilities dot secondary color, not the primary. And we'll also give it a size. So we're going to call set preferred size, and then it's going to accept a dimension object. And in dimension, we can pass in the pixels that we want. So for the width, I found 200 pixels to be good. And then for the height, we're gonna make the users list take up the whole height, and to do that, we can actually call a method called getHeight. This method is from our client GUI because we extended from the JFrame. So when we call getHeight, it's gonna get the height of our frame. So for example, in the beginning, if we don't resize it, the height value will be 685. So next we're going to create the label to identify what the left side is going to be. And so we're gonna create a J label, call it connected users label, and accidentally misspelled. Let's call this connected users, not connected user. So I'm gonna refactor it. You can just, if you're using IntelliJ, you can highlight it, right click it, and we're gonna go to refactor here, and then we're gonna click on rename, and we're just gonna add the S here, and then we're gonna hit enter. So what that does is that it actually updates all instances or wherever we called connected users, and updates the name to all those instances, as you can see here. It's something small, but for better readability later on. So we're going to instantiate this JLabel, and then in the text we're going to call it connected users. So this label is just used to identify what the left side is going to be. And now we're going to configure this JLabel. And the first thing we're going to do is we're going to edit the font of it. So the font style, font size, and then the font weight. So we're going to call set font, pass in a new font object. And here I'm going to use the inter font family. And then we're going to make it bold. And we're going to give it a font size of 18 pixels. And actually, let's add in one more color. We're going to call this text color. And here we're just going to give it white. And the main reason why I made it like this is so that we can configure it later on. So for example, since we're currently using primary color and secondary color, right? Well, what if we want to change the color, right? Well, we can easily do that by just changing the hex value of this color, and then that updates the rest of our GUI that utilizes or uses this primary color. So it's a lot easier to configure our GUI that way. So we're just gonna call connected users label, set foreground, and we're gonna call on utilities text color. And once we've done that, we have to add this label to our connected users panel. We're going to call the add method, and we're going to pass in the connected users label. So now we have added the JLabel to the connected users panel, but we still need to add the connected users panel to our GUI. And we can do that by calling the add method directly, and we're going to pass in the connected users panel. And something to note is that by default, JFrame has a layout manager, border layout. So here in our connected users panel, we set its layout to be box layout. Normally JPanel has a default layout of a flow layout, and it looks like this. I'll show you examples of each layout as I mention them. And for border layout, it follows this layout manager. So we can put it in the north, left, or west, south, east, or center. And in this case, like we mentioned, we want it to be on the left side. So in the second parameter, what we're going to do is we're going to call border layout, and then we get to choose the positioning of our panel, and we want it to be on the left side or the west side. I don't get why they call it west, east. I think it'd be a lot easier if you just say up or top, down, left, right, but that's just me, I guess. So once that's done, let's actually test this out now. So let's run the code. And there you go. It's not perfect, but we're gonna get there. All right, so let's close this again. All right, so next we're gonna work on the chat component, which is gonna be where the messages are gonna pop up and where the input field is gonna be. So let's go back here and let's go to our add GUI components method, and we're gonna create a new method called add chat components. And let's create that method now. Private void add chat components. So first we're going to create a JPanel, call it chat panel, and we're going to instantiate it. And as a reminder, JPanel's default layout manager is the flow layout, and here we're going to want it to be a border layout. And the reason why we want to do that is because of our design. And in our design, we're gonna make the display where the chat messages are gonna appear at the top, and then we're gonna make the input field appear at the bottom. So for the chat panel, we're gonna set the color to be transparent. And the reason why is because when we add the when we add this chat panel to our frame, it's going to have that default color. And by making it transparent, we get to see the background color of our GUI, which is what when we set it to the primary color. You'll see what I mean in a bit. So now we have the chat panel side. Let's build the message panel side. So message panel is actually going to be a global variable, because later on we're going to create these message components, which is going to contain the username and then the message, and then we need to dynamically create them and add them to our message panel. So let's go back up here, and then we're going to create the message panel variable. Let's go back down. And then here we're going to instantiate the message panel. And just like the users panel, we're going to also set the layout to be the box layout, because each message is going to appear underneath each other. So message panel set layout, new box layout, and then we're going to pass in the message panel and then the axis or the orientation that we want, and we want it to be vertical. So it's going to be in the y-axis. So we're going to say box layout dot y-axis. And then we're also going to make the background be transparent. Oops. And we're going to need to add the message panel to our chat panel. So we're going to say chat panel dot add message panel. And since we're using the border layout manager, we have to pass in a second parameter, and it's going to be the location. In this case, we're gonna want the message panel to be in the center. Now we're gonna add the chat panel to our GUI. So we're gonna call the add method and call chat panel. And then again, since we have to pass in the location we want, since we're using border layout for the main GUI too. And here we want this part to be on the right side, but you would think we would choose east because that's the right. But the way border layout works is that if we put things in the center, it takes up whatever space that's free. So that's what we're gonna do. We're gonna give it center because it's gonna be more malleable and take up any of the unused spaces. Before we test it, let's add a simple message into the message panel. So I'm just gonna add a random J label to the message panel. Say new J label, and then we're going to pass in the message. I'll just say random message, and let's launch this app. So it's kind of hard to see, but it's like right here. Let me actually create a message object so we can change the font and color, and then we're just going to pass in this message into our message panel. So now let's run the app again. And we should see the text much better. There you go. So right now it'll appear right here. Here's the chat panel, and then within the chat panel we'll have the message panel. And notice the transparent background. So if we try to move the transparent color background, let's see what happens. So if we do that, notice how there's like this default color that's already assigned to the panel. So that's why we use the transparent color, to make sure that it doesn't have any color and it'll just display the GUI's background color. Let's go back and uncomment these lines of code. Alright, so the next thing we're going to be working on is we're going to add the input field where the user can type in their message. Let's go back to our add chat components and then create a new JPanel, and we're going to call this input panel. And we're just going to instantiate it. Also give it a border layout. And then make the background color transparent. Alright, so next we're going to create a JText field, which is used in Swing to create the input field. We're going to call it input field, and then we're going to instantiate it. And then for the input field, we're going to configure our input field. So first we're going to change the background color to be the secondary color, so utilities.secondary color, and then we're going to make the text color white. So we're going to set foreground utilities.text color, and then we're going to change the size of the font or the text that's going to appear when the user is typing. So we're going to call in the set font method, new font, the font family, font style. We're gonna make it plain, not pain, but plain. And then we're gonna give it a size of 16 pixels. And based on design, I think it looks better if the width or if the height of the input field is just a bit smaller than the whole area of it's given, just because it makes it a lot easier to see the input field. So for that, we're gonna have to set a preferred size and pass in a new dimension. And for the width, we're gonna want it to be the full width of the input panel. So we're gonna call input panel get width. So it's gonna take the full width of our container, which is gonna be the input panel. And for the height, I'm gonna make it 50 pixels. So now we're gonna add this to our input panel. So input panel.add input field. And here by default, you don't necessarily need to put a second parameter, but it's automatically gonna put it into the center. And in this case, that's what I want. But I guess for better readability, I'll just state it for now. So border layout, center. Now we're gonna add this to the chat panel. So chat panel add input panel. And then, so the message panel is going to appear on the center, and for the input panel you want it to appear below. So we're going to say border layout, and then we're going to pass in south because it's going to appear below the center. And let's check it out. So here we can see the input text field, and if we start typing we can see the text. So actually the next thing we're going to be working on is we're going to actually implement a padding feature. And if you don't know what padding is, it's a way to add space between the content. So for example, here the content would be our connected users label and then the users list panel. And padding is a way to add space. Unfortunately, Java or Swing doesn't support padding, so we have to do a workaround and implement our own logic for padding. So we're going to go back to the utilities, and we're going to create this method called add padding. It's going to return us an empty border, which is basically a border that's not visible. That might be a bit confusing, but you'll see what I mean. In the parameters, we have a top, left, bottom, and right. And the values we pass in here will be the amount of space that we want for each side. And visually, it works similar to padding. But what's actually happening is that we're basically creating a border with this thickness, but we're just making it transparent. So you don't actually see the border when we add it to the specific components. So let's start using this right now. So let's go back to our client GUI. And the first thing I want to add padding to is the users list, because the label looks a bit off. So we're going to go to our add connected users component. And then for the connected users panel, we're going to call that method, or we're going to call in the set border method. And then we're going to call utilities dot add padding. And for the values, I just want 10 pixels equally around the connected users panel. So we're going to say 10, 10, 10. And let's just launch it just to show you what I mean, or what's happening with it. So as you can see before, this text here was like hugging the side of this GUI. But by adding padding, there's like this 10 pixels of space, and even at the top too, that's been added because of our padding method. So let's add that to our text field now, because it doesn't look as good in my opinion. So for our input panel, we're going to call set border, and then we're going to call utilities.add padding. And for me, it's going to be the same 10, 10, 10, 10. And now let's take a look at it. And yeah, I think that just looks a little bit better, but again, you could leave it the way it was before if you liked it that way. And it just works, so you can still type in it. Nice. All right, let's close it for now. All right, so next we're going to start adding messages dynamically to our message panel. And first, what we're going to do is we're actually going to create another method, and it's going to be private. And it's going to return a JPanel, and it's going to be create chat message component, where it will take in a message object, And let's import this class from our project. The message component, the GUI component, is going to have the username and then the message, and then that will be wrapped in it, or that will be put into a container, and that's the container that we're going to return to and add to our message panel. So first we're going to create a JPanel. We're going to call it chat message, and this is the panel that we're going to be returning. We're going to set the background to be transparent, and then we're also going to set the layout to be box layout, and then we're also going to add padding to it. So the first component that we're going to add to this chat message will be the username. So it's going to be a J label. We're going to call it username label. And we're going to instantiate it. And then remember, in our message model, we can use the get method to get the username. And that's what we're going to store in to this username label. And I misspelled it. Yep. And then for this username label, we're going to change the font style, and then we're also going to change the color. Now we're going to add this to the chat message. And next, we're going to create the J label for our message label, or the content of the message. So J label, and then in our message object, we can get the message string. And we're also going to update the font and the text color. And then we're going to add this to the chat message too. And then lastly, we're going to return this chat message. So to test this out, let's delete the message, the random message that we created here. So we could just delete it for now. And instead, what we're going to do is we're going to call the add method again. But this time we're going to call on the create chat message component, which will take in a message object. So I'm just going to take message here, and then we're going to say the user is from tap, and then the message, I'll just say hello world. All right, so let's run this app again just to see how it looks. And there we go. Well, this is supposed to be plain text, so we're going to change that later. But as you can see, we were able to dynamically create our message into our display component, our message panel. Yeah. So let's close this again. And we're going to actually make this plain. So we're able to add messages by calling this method. So next, we're going to work on the feature of being able to type into our input field, and then when we hit enter, it should display that message into our message panel. So for that, we're going to go here into our input field, and then we're going to add a key listener. And a key listener basically listens for key presses, but it's going to listen to it if we are pressing any keys while the input field is focused. So here we're going to pass in the key adapter parameter. We can override these methods. The one we want will be key typed. We can delete this. And here we're going to check which key was pressed. So we're going to get key char. And then we're going to see if it equals to key event dot vk enter. So this condition basically checking to see if we hit the enter key while the input field is focused. So the first step that we're going to do is we're going to take the input from the input field. To do that, we're just going to store in the text. So we're going to call in the get text method. So then we're going to want to reset our input field to be empty again. And for demo purposes, I'm just going to add it to the message panel directly, because later on we're going to do it differently. So here we're just going to say message panel dot add, and then we're going to say create chat component message, new message, and then for the username I'm just going to say tap. And then for the message we're going to put input. So here we're just going to delete this example, and that should be good. So let's run the app. So I'm just going to type in the message. If I hit enter, So it doesn't appear, and I just remembered why. So that issue happens is because for Swing, whenever we want to add new things, we also have to refresh the GUI. And here we're going to call in two methods called repaint and revalidate. And together they just basically refresh the GUI. So let's just check it out now. So let's type in a message again, hit enter, and there you go. So it looks pretty neat. We got the username, message, and we can type in more message. But what if we just have an empty message like this and hit enter? Yeah, so that's not good. So let's go with this for now. So that's an edge case. That's what we like to call an edge case. So if the input is empty, then we're gonna want to return. And what that basically means is that if the input is empty when we hit enter, it's going to return here and it's going to stop executing the rest of these lines of code. So as a reminder, this is an edge case, so an empty message, and this is just a way to prevent empty messages being pushed into the GUI. So let's test it again. So we can type normally, but if we just have an empty message, nothing's happening. So that's good. Alright, so in terms of functionality, we have most of what we need to continue with our GUI. So the next thing we're going to add is the Stomp client, so that we can connect our GUI to the WebSocket, or connect our client GUI to the Stomp client that connects to our WebSocket. So first we're going to go back up here into our constructor, and we're going to make a global variable. We're going to call it, or we're going to stomp my stomp client, or we're just going to call it my stomp client. And then also I'm going to create another variable here, which will take in the username, as we'll be needing it later on as well. So I'm just going to say this username equals username. And then for this, for our my stomp client, we're just going to create a new my stomp client instance where we need to pass in the username, which will just be the username. And we're getting an error here because we still need to throw the exceptions, which is going to be the execution exception and the interrupted exception. So since we now have our my stomp client connected to our GUI, this means that whenever our GUI is instantiated, our stomp client gets instantiated too. And when our stomp client gets instantiated, if you remember, is that we try to connect to the WebSocket. And then after we connect to it, we will send our username to the connect route. So this will just connect our GUI. So basically it's just connecting our GUI to the WebSocket. So here we can finally test the disconnect user method when we close our GUI. And we could do that when the user chooses the yes option when the exit dialog appears. So if we go to our window closing method, so before we dispose the GUI, we're going to call on our stomp client, and we're going to call on the disconnect user method and pass in our username. So what's going to happen here is we press yes, we're going to call in disconnect user method, and let's go back to the my stomp client class and look at what the disconnect user method does again. And the disconnect user method will send this username to this route. And let's go to our controller to see how the method processes the username, and it just removes it and then broadcasts. So we're going to test this out. So if your WebSocket server isn't running, make sure that it's running. So we're going to launch our WebSocket server. Oh, right. So I guess, yeah. All right. So yeah, so here we're going to also try to catch the exceptions that we had before, and that should be good. So let's try it again. Let's run the WebSocket server again. If yours is already running, then you don't really need to do anything, because we didn't really change much in the controller or any of the WebSocket stuff. So once the server is loaded, let's go to our app configuration and let's launch the app. Alright, so if we look into the console, we see that it says client connected, and then we also subscribe to this route. So let's go to the WebSocket server real quick. So here, it seems like we broadcast in the WebSocket server, it broadcasted the user's array list to the user's route, and also shows us that we've connected successfully. So what I want to test out is the disconnect user method. So when you press X, our dialog will appear, and if we click on yes, we're going to call in the disconnect user method. And let's click on yes now, and as you can see here, it broadcasts the new list, which is an empty because we remove tap from that list. And we also get this message here that says tap disconnected, which is what we want, so that's good. Alright, so let's go back to our client GUI. And the next feature that we're going to add is the ability to send messages from the client to the WebSocket. So to do that, we're going to have to go down here to the input field that we just created. So after we retrieve the text, make sure it's not empty, and reset the input field, we're going to send the message to the WebSocket. And in order to do that, we're going to call on our stop client, and then we're going to call on the send message method, which will take in a message object. So we're going to instantiate a new message object where we're going to pass in the username and the input, or the user's message. So how this is going to work is that we pass in this message instance into the send message parameter. And if we go back here to this my stop client class, we can take a look at the send message method again, and all it does is sends the message object to this route here, and then in our controller, this is the method that's going to process our message object. We should be seeing these two messages or into our console. So let's run our app again. All right. So if I type in a message, like let's say hello world, here we can see that it said message sent and then receive message. And then if we go to our WebSocket server, we can see that we do get those messages from here where it says receive message from user, and then it's just the username and then the message. And then here we could also see that we sent this message to the topic messages route, which is why in our app we were able to receive that message. Because if we go to our MyStomp session handler and look at these lines of code, we subscribe to this route where the WebSocket sends the messages to. And based on that, we have our stop frame handler, which handles the incoming data from the WebSocket server. So if we take a look into the handle frame method again, we're going to first check to see if the payload that we've received from the WebSocket server is of message type. And if it is, then we're going to convert that data into a message object and store that into our message reference here, and then output the incoming message or incoming data. So everything seems to be working just fine, which is good for us. So let's head back to our client GUI, and I'm gonna close the... Actually, before that, I do want to update the GUI a bit more because I really don't like how close the text is to the input field. Like, I think it looks better if there's a little bit of spacing. So for that, we're going to be adding padding like we did with the text and even with this input field here. So we're going to close this and then go down here where we configured our input field settings. And I'm just going to put it right here. So input field dot set border utilities dot add padding. And what we're going to do is just add padding to the left and right side. For the top, we're going to put 0. For the left, we're going to put 10. And then for the bottom, we're going to put 0. And then for the right, we're going to put 10. So let's run this again. Let's take a look. Yeah, I think that looks way better. And then if we reach the ending, because that's why we need a padding on the right side too, because it just looks better on the right side as well. But I guess it probably doesn't matter. Want it to be 0, you can make it 0. Alright, so remember I said that we're going to delete this lines of code because we're going to be updating the message panel based on the messages that we're going to be getting from the WebSocket. So we're going to delete this. And let's talk about how we're going to do that. So we'll need to find a way to update our GUI when we receive a message from our WebSocket server. And note that the class that handles the incoming messages from the WebSocket server is from our MyStomp session handler class. So how do we update our GUI from this class? And one way we could do it is we could create an interface. an interface that would basically act like a listener and implement that listener into our client GUI class, and then use that listener here. So whenever we get a new message, it'll call on the method from the listener class, which our client GUI has to define in its class. So we're basically calling the method that we're going to use to update the GUI from our listener from this class. I know that was probably a bit confusing, so let's just do it, and maybe you'll understand once we implement it. So we're going to highlight our client package. We're going to right click it. We're going to add a new Java class, and then here we want to select interface. So for the name, I'm going to call it message listener. We're going to hit enter. And in this interface, we're going to have two methods. We're going to have on message receive, and it'll take in a message object. Let's import the message class from our class. Oops. So we're going to import the message class from our project. And the second method is when we're going to use it to update the list of users to our GUI. So we're going to call it on active users updated, and it's going to take in an array list of strings, and we're going to call it users. And we also need to import the array list class, and it's from the utilities class. And yeah, so that's pretty much all we need to do for this class or this interface. So we can close this for now. And then in our client GUI, we're going to go all the way up here to where we declared our class, and after we extend JFrame, we're gonna use the implements keyword, and we're gonna implement our message listener that we just created. And it's giving us an error because the methods from our message listener interface haven't been defined yet. So let's implement those methods now. And as you can see here, these are the two methods that need to be implemented or defined. For now, we're going to be working on this for now, and then we'll be working on this next. So here on message receive, so let's actually test this method out so you'll understand better what I mean, how we're going to use this interface. We're going to say we're going to call system.out, and we're going to say on message receive. So when this method gets called, it's just going to output this to our console. So now that we have the message listener implemented, we're going to need to also pass in that reference into our MyStomp client, and then pass that down to our MyStomp session handler. So in our MyStomp client, we're going to update the parameters. So after the username, actually no, we'll do it before. So before the username, we're going to require a message listener reference. We're going to call it message listener. And then when we go to our MyStomp session handler, we'll also be updating the constructor as well to take in a message listener reference. So we're going to do the same thing where we create a new parameter, call it message listener as well, and we'll be creating a global variable for it as we'll be using it in our after connected method. So message listener, and then this message listener equals message listener. So now we'll be getting some errors because if we go back to our client GUI, we'll need to pass in a reference to a message listener reference. And what we can do, since our class implements it, we can just pass in this keyword. So just like how we needed to update this constructor with the message listener interface, we have to go to our MyStomp client to update the constructor call or the instantiation of the MyStomp session handler and pass in the message listener to the object creation. And that should be good for now. So in our MyStomp session handler class, when we get the message, let's just call in the method. Let's just call the method. So for example, let's just call it over here. We'll say message listener. We could use one of these methods, and we're just going to use on message receive because that's where we added that system.out. So for the message, I'm just going to put a random message object because we're not going to use it just yet. Oops, this needs to be string 2. All right, so let's run this again. So the idea here is that when we send a message in our client GUI, we're going to call on the send message method from our MyStomp client, which will send that message to our WebSocket, which will process that message and then send it to this route here, where in our MyStomp session handler, we subscribe to that route, and any data that gets sent to this route will automatically be handled with our frame handler. And when we get that message, we're gonna call on this method, which will check first to see if it's a message, and then if so, then we're gonna call on the onMessageReceive method, which this method will refer to this method definition here. Let's go back to our GUI and let's just type in hi. We don't get the update in our GUI because remember, we removed that code. Instead, we're gonna look at the console. So as we can see here, onMessageReceive is what we system.out in the onMessageReceive method. So it does work. So now what this means is that whenever we get a message from our WebSocket server, our MyStomp session handler will process that message and will call on our GUI's onMessageReceive method, which will update the display with that new message. All right, so now let's do this properly. First, what I just realized is for here, we could have just moved this down below and then pass in the message reference that we have here. So let's close our GUI for now. And let's go back to our ClientGUI class, and now let's properly define this method to update our GUI with the new message that we received from the WebSocket. So the first thing we're going to do is we're going to call on message panel, and then we're going to call on the add method because we'll be adding a chat component to it. So we're going to call on the create chat message component, and we're going to pass in the incoming message that we received from the WebSocket. And then remember, we have to call on the repaint and revalidate method to refresh the GUI so that any updates to the GUI gets added in properly. And that should do it. So let's run the app again. So I'm just gonna say hi. Oh, that's all right. So actually we need to call revalidate first before repaint. So let's run the app again. All right, so if we type in a message like hi, there you go. So now it appears, and this message is actually coming from the WebSocket server. And the reason why I designed it like this is because it validates that the user's message went through to the WebSocket server, and this means that you know that your message went through the WebSocket and that people were able to see it. So the next thing that we're going to start working on is to display the list of users into the connected users list, which is over here. And yeah, so let's close this for now. So the one thing we haven't done yet is subscribe to the topic users route, which if we look at our WebSocket session manager class, we can see that we're sending the list of users to this route. And so far, if we look at our MyStomp session handler, we only subscribe to the messages route. So even though our WebSocket server is sending the users list to the topic/users route, we're not able to get it yet because we haven't subscribed to it. So let's subscribe to that route now. So we'll go down here, make some space, and then we're going to call session. We're going to call on the subscribe method, and we're going to pass in this route, users. And then for the second parameter, we'll need to pass in a stomp frame handler instance, in which these two methods will be overridden. And what we will be returning is new array list string and then get class. So now let's go to the handle frame method, which is where our client is going to process the users list that's going to be sent from the WebSocket server to the /topic users route. So we're going to create a try catch block in which we're going to catch any exceptions that happen. And we're just going to call print at stack trace, which just prints out the exception that occurs. And then here we're going to have a if condition where if the payload, which is the data that's going to be sent from the WebSocket server to the /topic users route, and we're going to check if the type of that data is of an array list type. If it is, then we're going to want to retrieve it. So we're going to create a local reference to it. We're going to create an array list, call it active users. And then we're going to need to cast the payload into an array list of string type. And now if you remember in our message listener class, we also have a method called onActiveUsers method, which we're going to pass in our active users array list. And I'm just going to debug here and say that we received active users, and then we'll just output the active users. And then I'm just gonna go over here and then output subscribed to /topic/users route. Alright, so now what we just did is that we created the subscription code that will allow our client to process the incoming data from the WebSocket server to this route here, where in our WebSocket session manager, we're going to send in the active usernames array list to that route. Alright, so everything looks good in our Stomp client code. So let's go back to our client GUI and let's start defining our active users updated method so that we can update our GUI properly. So the way I designed this feature to work is that there will be a user list panel, and in this panel we'll be adding each username as a JLabel. The issue with this is that we will need to remove the user list panel each time the list is updated to prevent the list from being duplicated. You'll understand what I mean in just a second, but if you guys do find a more efficient way of doing this, leave it down in the comments, as it would really help not just me but other people who are also interested in making this more efficient. So first, I'm going to check to see if the connected users panel, and we're going to get the components and see if the length, the number of components, is greater than or equal to 2. If so, then we're going to remove the first component, or the second component actually, which is going to be the users list. So if we take a look into what this actually is doing, let's check the connected users panel again, which we created in here. So it's a J panel, and it's only going to have 2 components at most, and that's the way it's designed. So the first component, which is going to be at index 0, is going to be this JLabel here, which is going to be the connected users label that you saw earlier in our GUI. And then the second, which is going to be the users panels list. And we haven't created that just yet. We're going to create it just a second. I just wanted to point this out. So let's go back down here, back to here. And then I'm just going to add this comment here, just in case if you want to look into it further. So here, now we're going to create that second component which is going to be added to the connected users panel, which is going to get removed every time we need to update the users list. So we're going to say JPanel. We're going to call it user list panel, and we're going to just instantiate it. And then here we're going to set the background color to be transparent. Then give it a box layout, where we'll pass in the user list panel as the first layout, and then the axes that we want, which is going to be the Y axes, because we want them to be in a single column. And now, since we have the reference to the users list because of our parameter here, we're going to iterate through each one. So we're going to create a for each loop where we're going to say for string user in users, we're going to create a JLabel, and we're going to call it username. So for each username, it's just going to be a JLabel object. So we're going to instantiate the JLabel, and then we're going to set the text to be the user, which is going to be the username. And now we're going to configure it. So we're going to give it a foreground or a font color of white, or our text color. And then we're going to change the font. So we're going to say set font, new font, the font family, font style, which is going to be bold, and then the font size, which is 16 pixels. And then now we're going to add this to the user list panel. So user list panel dot add username. Alright, so now we added each username to our user list panel. Now we have to add the user list panel to the connected users panel. So connected users panel dot add user list panel. And we'll want to repaint and revalidate so that we could refresh. Or in this case, we'll revalidate first and then repaint after. So again, if you don't have your WebSocket server running, run it now. Now let's launch the app. And there we go. So we can see here the username TapTap is now displayed into our connected users list. And then if we look at our terminal, we can see that we subscribed to the topic users route successfully, and we also received the array list or the users list from our WebSocket server. And if we go to the WebSocket server, nothing should change because we didn't really change much in the background. But I like to point out that we do broadcast the array list to this route, which is when our client received it right here. And then let's try creating another client to see if this actually updates with this client here. So to do that in IntelliJ, we're going to actually create another configuration, and it's going to be similar to app. I wonder if we can clone it. So we're just going to create another application configuration. We're going to call this app2, and it's just we're going to use the main method from our app class. So we're going to OK, and then we're going to hit apply and OK. And then now in app2, note that app1 is still running. So app2 we're going to execute. So in app1 we could see that there's two usernames now. But if we go to the second one, it's empty. So the reason why it does that is because there's some syncing issue, because by the time we connect with the second client, the WebSocket server is already sending the users array list to the users or the topic users route. And by the time it sent it to that route, our second client was still connecting, so it wasn't able to successfully retrieve that data in time. So now we're going to work on solving this issue. So for now, we're going to close both of these clients. And notice that when we close the second client, our users list updated to that. So that's pretty cool. All right, so we're going to close this one too. All right, so now we're going to work on the back end again. So let's head over to our WebSocket controller, as we'll be creating a new route. So in this route, we're going to call in the message mapping annotation. And then the route that we're going to name it as is going to be called request users. And then we're going to create the method that will handle the incoming data from this route. So it's going to be called request users method. And then here, what we're just going to do is we're going to call session manager, and we're just going to broadcast the user's name. And then I'm just going to debug here and say, I'm going to call it requesting users. And to combat that issue of having to wait or having to sync our client so that we're able to get the data in time, we're going to go to our MyStomp session handler, and after everything here, which is after it connects, after we subscribe to the topic messages in the topic users route, then we're going to request the users list. So we're gonna call in session dot send to the app / request users route, and for the payload we'll just have it send an empty string, because method doesn't really accept anything, but it still wants an object to be sent. So what's going to happen here is that after everything we did for this method, we're going to call on this method here, which is going to broadcast which is going to call on the broadcast active usernames, which is if we look at here in this class here, which is going to send the active username list to the topic users again. So it's basically like telling the WebSocket server to resend the username list after we make sure that our client is connected to the user's route. So this guarantees that our client will always get the user's list whenever we try to enter or sign in. So let's test this now. So first we're going to go to our first client and we're going to execute it. So this is our first client, and now we're going to execute the second client. And there you go. So here is the first client and here is the second client. And as you can see here, the users list is successfully retrieved from both clients. So that's good. All right, so now let's work on, so we don't want to hard code our username every time we launch the program, because that's not a good user experience. So now next we're going to implement a way to have the user type in the username they want and make that their username when they connect to the WebSocket server. So to do that, we're going to go to the app class, and right here we're going to actually create another pop-up or a dialog using the JOptionPane class, and it's going to be called JOptionPane, and we're going to say show input dialog. So the first parameter that we're going to pass in is null, and this means that initially our input dialog will appear at the center of our screen. And then for the second parameter, which is going to be the message, the message that it's going to ask the user. So in this case, we're going to type in enter, we can put it in a separate line, enter username. So, and then for this program, we're going to actually limit the character count of the username, as it does break the UI a bit if the character limit passes a certain amount. And for our case, we're just gonna limit the username count to 16 characters. And then for the third parameter, it's just gonna be the title of our header, which we're just gonna say, we're gonna pass in a chat or a string, call it chat application. And the type of message that we're gonna, or the type of input that we're gonna be showing, or the type of input dialog we'll be showing, will be a question message. So this last part, or this last parameter, is just gonna display an icon that helps identify what type of dialog that's appearing. And just like the other option panes or other dialogs we made, it's gonna also return a value. In this case, it's gonna return a string of what the user typed in. So we can actually store that in a reference or in a variable. We're gonna store that into a string object. So we're going to say string username equals the value of this. And now we're going to enforce our limit of 16 characters and also do some edge cases. So the first edge case is we're going to check if the username is null. And if it is, it means there's an error. You want to make sure that the username is at least has one character. So if the username is null, or if the username is empty, or if the username dot length is greater than 16. So these are the conditions where it will fail. And if it does fail, then we're going to show an error message. So again, we're going to be using the JOptionPane. So here we're just going to say show message dialog, and then for the parent we're just going to say null. For the message, we're going to say invalid username. And then for the title, we're just going to say error. And then for the message type, we're going to say error message. So JOptionPane error message. And then after showing the message, we're going to call on the return keyword. So this basically means that if any of these fail conditions are true, then we're going to show an error dialog. And then once they interact with that error dialog, it's going to return or stop executing the rest of the code. But if the username is valid, then instead of hard coding the username here, we're going to pass in that username value that we got. All right, so now let's test this out. So I'm going to test it out. I'm going to test it at app 1. And here, so here is the dialog, the show input dialog that's running right now. So first, let's try to invalidate our input. So we're just going to leave it empty. And as you can see here, we do receive that error dialog. And if we hit OK, it just terminates our program because of this return keyword. So let's run it again. So now let's enter a character that's greater than 16 characters. I'm just gonna type in a long character that I know is more than 16 characters, and let's hit OK. Invalid username. So that's good. So now let's just enter a valid username. And I'm just gonna call this user1 and hit OK. And there we go. So we have our new user, and then our header here now says user1 and then user1 username in the connected users list. Let's type in some messages. So let's just keep typing some messages here, and then wait a minute. All right, so now we can't view the messages that are happening or that are being created below. So let's work on this issue next. Let's close this for now. So let's head over to our ClientGUI class. And we're gonna go to the chat components method, and here, this is where we're gonna fix that issue we were having. So the reason why we weren't able to view the messages that were being added below is because JPanel by default isn't scrollable. So that means that there's no way of scrolling our JPanel to view the messages that were being added to the JPanel. So in order to do that, we need to create a scrolling container called jscrollPane, and we're going to create a global variable for it because we'll be accessing it throughout this class. So under the username, we're going to say private jscrollPane, and make sure to import that class. We're going to call it message panel scroll pane. So we're going to go back down here again into our add chat components method, and below the message panel configurations, we're going to initialize the scroll pane, and here we'll need to pass it the component that we want to add the scrolling ability to, and in this case it's going to be our message panel. And now we're just going to configure our message panel scroll, we're going to make the background transparent, and then we're going to set the vertical scroll bar policy. And what this does is that we're able to control how our scroll should behave. And in this case, how we want our scroll pane to work is that we only want the vertical scroll bar to appear if it's needed. So in our case, if we have just a couple messages, then the vertical bar or the scroll bar won't appear until we start having more messages. And then another thing that we're going to do is we're going to get the vertical scroll bar, and then we're going to set the unit increment to 16. So this basically allows us to control how fast the scroll should work. So by default, it's very slow, but I found 16 to be a good number for the scroll speed. And now, instead of adding the message panel, we're going to be adding the message panel scroll pane. And that should do it. So let's run our app. So we're going to enter in a username, user1. And now we'll just start adding in messages. And yeah, so in the beginning, as you saw, there wasn't any scroll bars. And that's because of our policy that we made. And we only want the scroll bar to appear if it's necessary. And in this case, it is necessary because we can't see the new messages anymore. And so if we scroll down, we do get this UI bug, which occurs because we needed to revalidate and repaint the GUI again, just like we did before. And something to note is the speed of the scroll bar, because that's what we configured to be. It's gonna do 16 pixels and I just thought it's a good speed. All right, so now let's fix this UI bug here. So let's close this for now. So in order to do that, we want to repaint, revalidate every time we scroll. And for that, we're going to add a change listener. But first we need to get the viewport, and then we're going to add the change listener. And here we're going to pass in a change listener in this method state change. This method gets called whenever we scroll. So this is perfect for our issue. All right, so now we're just going to call on the revalidate and repaint. And then now let's run the app. Just going to put a random username again. And then we're just going to start typing in random. All right, so now when we scroll down, it's a bit iffy, but for the most part it works. So I think it's good enough. So another issue that I just noticed is that sometimes the users doesn't appear, and I'm thinking that's probably because if we go to our MyStomp session handler, we're connecting. We need to move this line of code just before we request it. So I think if you were facing some issues with the connection, hopefully this solves it. So yeah. Alright, so another thing to point out is that for user experience, it's kind of a hassle to have to scroll down every time a new message appears. So next, we're going to work on this by making sure to automatically scroll to the bottom every time a new message appears. So let's close this. And then let's go to our ClientGUI class. And let's scroll down until we go to our onMessageReceive method. And then after we created the chat message and then we validated, repainted, we're going to call on our message scroll pane panel, message panel scroll pane, and then we're going to get the vertical scroll bar, and then we're going to set the value to be the max value. So what this is going to do is we can actually set the value of our scroll bar, and that will just allow us to place our scroll bar depending on where we want it. And in this case, if we pass in the max value, it's always going to be at the end, which is perfect for what we want to do, because we want the message, or we want the scroll bar to go down every time a new message appears. So here we're going to type in just another username again, and now we're just going to type in a new message. So now we reached the end, so let's see what happens when we try to type in a new message. Nice, so now we can see that new message here, and we can still scroll. So we'll just type in more messages. Yeah, and you can also do this with the user connected users list too, but I'm not going to do it for this video. I'm going to leave it to you guys as a challenge to do. And what I might do is have the solution in the GitHub. So if you're really interested in how to do it, you can just check the GitHub to see how I did it. And also, again, if you're liking what you're seeing and what you're learning, please leave a like and subscribe. Thank you. So we're almost done with our GUI. This next part is optional, but it makes it more UI friendly. That next part we're going to work on is basically wrapping the text. So if the text gets really long like this, when we hit enter, we're just gonna work on wrapping the text so it fits the container only, so that the user doesn't have to scroll horizontally to see what someone said. All right, so we're gonna close this. So the way that we're gonna handle this issue is by using a bit of HTML magic, and then also using some listeners for when the size of our GUI changes. There are probably better ways of doing it than this, but I found this to be the most simple. So if you guys have any other solutions, feel free to leave them down in the comments. Alright, so first we're going to go to this method here, the create chat message component method. And then where we set the message label, or where we set the message text, we're actually going to remove this. And instead, we're going to call on the set text method. Now we're going to pass in, now we're going to do some of the HTML magic, which Swing does support. And first we're going to create the HTML opening tag and then the closing tag to indicate that we are going to be using HTML. And I like to do it like this so that it helps with formatting and it's a lot more readable. So the next thing we're going to need is we're going to need the body tags. So we're going to create the opening body and the closing body tag. I'm just going to do that. Don't worry, it just looks a bit messy for now, but once I organize it, it'll look better. Alright, so now we have the body tag, and then in between the body tag will be the content. So in this case, it'll be the message dot get message string. And don't forget the plus, and that looks good. Alright, so for Swing, it does support a bit of styling. So we can actually use the inline style. We can control the width that we want. So here we're gonna call width colon, and we're gonna put a quotation mark, and then we're gonna calculate the width that we want. And in this case, we want this container or this label to be 60% of the current width. And you could test this value out. You can change the 60 to 70 or 80 or 50 and find a better number for yourself. For me, 60 is like, I feel like is a good number. And then after that, we're going to add in another quotation mark, and then we're going to add pixels at the end, or px. So just by itself, it's not dynamic. So even if we change the size of the GUI, it's not gonna adjust to it just yet. And I guess I could show you guys what I mean. So let's run the app. Go and type in user1, and I just enter a decent sized message like this. Hit enter. Oh wait. Oh, alright, so I actually forgot to add in this other single quote. That's why we weren't seeing it. Alright, so let's rerun the application again. So let's type in user1, and now let's just type in a big message like that and hit enter. So as you can see here, instead of overextending and overexceeding the width of our display area, it actually wraps the text. But let's try increasing the size of our GUI and basically doing the same thing. So I'm just gonna do this a lot faster. Just copy and paste, and then let's hit enter. And notice how it's a bit bigger than before. And even though, like, let's say we make it smaller, it doesn't actually adjust. And this is what I meant by being static instead of dynamic, is that it's not readjusting based on the size of our GUI or resizing of our GUI. So that's what we're going to do next. We're going to close this. Yeah, so we need to add a listener for when our GUI gets resized. So let's go up to the constructor again, where we create our constructor. And after we set the window listener, we're going to call on add component listener. And here we're going to pass in the component adapter. And here are the methods or the listeners that we can listen to. So we can listen to when it's resized, when it's moved, when it's shown, or when it's hidden. In our case, we want to do something when our GUI gets resized. So we're just gonna override this method. So we hit OK. And for the method, we're actually gonna create another method called update message size. So it's giving us an error because we haven't made it yet. So that's what we're gonna do now. So we're gonna scroll all the way to the bottom. And then we're gonna create this new method. So we're gonna say private void update message size. So the goal of this method is to iterate through all of the current messages that are in the message panel, JPanel. Then we're gonna be updating the width value for each message by calculating 60% of the current width of our GUI. So for that, we're going to have to create a for loop, and then say message panel dot get components dot length I++. So we're going to reference the component at message panel dot get component I, and then we're going to check if this component is an instance of jPanel. So we're basically checking if this component is of jPanel type, and if it is, then we're going to store that into a chat message jPanel. We need to cast it to a jPanel, so we're going to say message we're going to cast the component to a jPanel. So next, we're going to check. So in this chat message panel, it's going to, and remember, it's going to contain the username label and then the message. But for type safety, we're also going to check to see if that component that we're going to get is of JLabel type. So here, so what this panel contains is it's going to contain all of the chat message panels that we have here, and in our chat message we're going to have two components, which is going to be the username label and then the message label. So if we go down again, so here I'm going to only make sure that it updates the message label only, and since we know that chat message only has two components at most, and that we made sure to add the message label at the end, we know that the index of the message component is going to be at the second index, or index number 1. So then we're going to check if the chat message get component at index 2, or index 1, which is the second value in the list, is of JLabel. This is just for type safety. And then if it is, then we're going to store that into a JLabel. So we're going to call it JMessageLabel equals, and we're going to cast it into a JLabel object, get component 1. And now what we can do is we can basically reset the text and recalculate the width based on the current width size. So we're going to call message labels. And I'm actually, to make it a lot simpler, we're just going to copy and paste this, because it was a bit of an issue to format it. So we're just going to copy this and paste it down here. So for the message, instead of saying message.getMessage, we're actually going to say message label .get text. Alright, so now let's test this out. So we're going to say user1, and now we're just going to type in a long message and enter. Alright, good. So now let's try resizing our GUI, and right now, as you can see, the text is reformatting to fit within our display. So I think that's good. So yeah, this improves the UI a lot in my opinion. Alright, so now we're basically pretty much done with our GUI. So now we can finally host our WebSocket online so that we can connect to it anywhere we want. So let's close this for now. So for this next part, you're going to need to make an account on Render, and also you need to have a GitHub account. So if you don't know, Render is a hosting site where we could host our web applications, including a WebSocket server. And also we'll be using Docker just for a little bit. And you don't need to know anything about Docker, as I didn't when I was trying to learn how to host this online, but it does help if you do. So when we do get to the Docker part, I won't go into detail as to how everything works. But if you are interested, I will leave a link to a video that helped me learn how to host the Springboot WebSocket project on Render. And he explains it really well. So if you're really interested in how it worked, then I suggest going to that video and see how he explains it. So if you don't have a Render account or a GitHub account, I suggest doing that right now. It's pretty simple and straightforward to do. And once you're done with that, you can continue following along. So first I'm just going to sign in. So actually one thing you could do is you could actually sign in. You can sign into render with your GitHub account. So technically you only need to make a GitHub account. Then you can just sign in or create an account with your GitHub account. So here I already have a test, but don't worry, we're going to create a new one. Alright, so first we're going to head to our GitHub account. Then what we'll want to do is we're going to go to our repositories, and then we're going to select this new button. So we're basically going to create a new repository. So here we're just going to call it Chat App WebSocket Server. You can add a description if you want. Here I suggest making it private, and that should be good enough. So we're going to create this repository. And once we're done here, so next we're going to be uploading all of our project into this repository. So you can do this if you have experience with GitHub already and Git Bash. You can upload it through the terminal or even through the desktop application. But for simplicity, you can also do it the way I'm going to be doing it, which is uploading the files directly. So if we take a look at here, we have an option to upload an existing file. So let's click on that now. It's going to take us to this, and what you'll need to do is locate your project with all of the files in it, and you're going to select all of it, and then we're just going to drag it and drop it to the repository like this. And now we'll just wait for a bit, and then once it's done, we're just going to, here we'll just say init push, or yeah, and then we're just going to commit the changes and then just wait for a bit. Now our project is located in GitHub, in our GitHub account. This will be important because in render, when we make our web app, we can select the repository that we want to use for the web app, and it'll launch that project from GitHub. So we still need to actually upload one more file, but we haven't created it yet. So let's head back to our IDE, and what we're going to do is in our root folder, so here we highlight the folder WebSocket demo. We're going to right click it, and then we're going to create our Docker file. So we're going to create a file here, and then we're just going to call it Docker file. You hit enter. So this step is important as render will read this Docker file to see how to run our Java code, as it doesn't support it right off the bat. This might get a bit complicated, but again, you don't really need to know this stuff unless you want to. But for the sake of this project, it isn't required. So remember the setup that we did earlier with Spring Initializer? Well, that's going to come in handy for this part. Also, if you had a different setup than the one I had in the video, now is the time to bring up that image I told you to save in the beginning, as it will be important when configuring our Docker file to run the Java application. If you did follow the same setup as I did in the beginning, you can just copy these lines of code. And again, if you want further explanation on this, click on the video that's linked below. So pause the video now so that you can copy it. Otherwise, if you have a different setup, like if you named the project differently, then you'll have to do some extra steps. Don't worry, they're pretty simple. For those that did copy my setup in the beginning, feel free to skip this part. So if your project setup was different, the only thing you need to change is the name. So what I mean by that is we're going to be changing these three names and replace it with the name that you put. So now that we added the Docker file, or now that we created our Docker file in our project, let's upload that to GitHub too. So we're going to go back to GitHub here. Then here we could add a file and we could upload files. Again, you could use the terminal if you wanted to. So we're going to locate that Docker file from our project, and then we're going to just drag and drop it. And then for the commit, we could just say add Docker file, and then we're just going to commit. And there we go. So we have our Docker file here now, and everything should be good to go. So let's head over to render. So once you made an account, you'll be taken to this dashboard, and then what we can do is create a new web app. In order to do that, we're going to select this plus new button here, and we're going to select web service. So right now, the only repository that we can connect to render is this test, which isn't what we have. So in order to configure our project to be selected in render, we're going to click credentials, select credentials, and then we're going to configure GitHub. So when that happened, this pop-up should appear and it should ask you for a password and just sign in normally. And when we get to this part, we're going to go to the repository access, and then we're going to select repositories. So we're going to look up that repository that we made, and if I remember correctly, we called it chat app WebSocket server. So we're going to select that, and then we're going to select save. And once that's done, the window should close, and now we could see that we can select that repository in render. And that's what we're going to do. So we're going to select it, and we're going to select connect. So as you can see, I already kind of configured the Docker image and everything else here. And you can just leave everything the same here. And it depends if you want it to be hosted in a different region. For this case, it doesn't really matter. So yeah, leave everything in here the same. And when we go down to the instance type, we're going to select free so that we don't have to pay for anything. So here you can choose to pay for a premium service if you want, if you do plan to make this project bigger and expect more users to use it. But since this is just like a hobby project, we're just going to select free. But there is something to note that if you are using the free version, your WebSocket server will be closed if it's left idle for 15 minutes. So once that's done, we'll scroll down here, and next we're going to select this deploy web service button. All right, so right now, as you can see, it's building, and this will take a while, so just wait. Yeah, so just wait it out, and I'll just cut it to when it's finished building. All right, so I actually did get an error here, and I think I know why. So let's head over back to our IDE, and the one thing I messed up on is this hyphen here is supposed to be an underscore, because that's the name of my project. And we could check that because over here you can see WebSocket_demo. Now we have to go back to our GitHub again, and then we're gonna upload the file again. We're gonna upload that Docker file that we made again onto here. So this is after. So if yours worked, that's good. That means you got the name right. For those that did follow, I apologize. This was from a previous project that I did, and I didn't realize the name was different. And so yeah, just re-upload the Docker file after you made that name update, and then just commit the change. So once that's done, let's go back to here again, and to redeploy our app. So it failed, right? So now we have to redeploy it again, and you can choose one of these three. For me, I like to do clear, build, cache, and deploy, just to make sure everything's like new and refreshed. So now it's rebuilding again, and just wait it out. We're just gonna wait it out. So I'll just cut to the video when it's done. All right, so when everything is finished, you should see this green box here that says live. So now our WebSocket server is hosted on render. Now you might be wondering what about it? Well, now the cool part about it is that we can connect our client to this WebSocket. And this also means that you can have a buddy or a friend or a family member connect to this same WebSocket server, so you guys can start communicating with each other. So to do that, we're actually going to use this link here. So we're just going to copy this to clipboard, go back to our IDE, and then go to My Stomp Client. And notice where we set the URL. Well, it's going to be pretty simple. All we have to do is just take this part of the link, remove it, and then paste in that link that we just made. Remove that extra slash if you do have it. And now what we can do is let's run this app and see what happens. All right, so we have this dialog. This doesn't mean we've connected just yet. So let's try just user 1, select OK. And there we go. We successfully connected to the WebSocket server that's hosted on render. And to make sure, if we go here, let's go to the WebSocket server. It's not currently running, so our WebSocket server isn't running locally at all. And let's go to our app 2 and let's run that. And then I'm just going to type in user 2. Nice. So now we have both of our clients here, and then we can just start communicating. Hello. and then it shows up here, and then we just say. So yeah, try this out with a friend or family and start communicating with each other. If you don't want to use Discord or anything like that, you could use your own chat application. How cool is that? Leave a like and subscribe if you want more content like this in the future. So I have a quick announcement that I want to share with you guys. As you guys know, I enjoy making these videos where I get to make these cool and interesting projects and share them with you guys. And I just wanted to announce that I've set up a Patreon page where you guys can support the channel so that I can continue to provide more content like this one. Feel free to check it out in the description below. I appreciate any support that you guys can give, so whether if it's through Patreon or just leaving a like and commenting, I am really grateful. Thanks for all the support, and I'll see you guys in the next video.